Okay, today what we're going to deal with is more proportional parts. Some are within triangles, and some are just formed by parallel lines cut by transversals. Okay, and you'll be able to see in some of these, they still tie together a little bit. Okay, so we're dealing with parallel lines, proportional parts. The resources, the notes I sent out, you've got 4 pages, good examples and diagrams, and the PowerPoint, Chapter 7, Section 6. Okay? So let's look at 3 things. The triangle proportionality theorem. Okay? Years ago, when I was stupid, now I'm less stupid. Okay? I used to tell people to memorize everything. Here's what I have said and what I want you to remember. For all 3 of these things, rather than saying, okay, this over this equals this over this, then this over, be consistent. Being consistent will eliminate an awful lot of mistakes you could possibly make. Because, like I've said repeatedly, the math itself is not difficult. Okay? The setup is the geometry. And that's where some people mess up because they're not paying attention. So here's what I want us to think about. Okay? Yes, we have 2 similar triangles here. Triangle ABE and triangle ACD. Okay? So all of those parts are in proportion. But we also have little segments like BC and DE. Here's what I want you to remember. If you're getting numbers in these segment parts, if you have one, you have to use the other. Okay? Because those are the only 2 parts of this diagram that are not sides of triangles. Watch. AB is the side of a triangle. BE is the side of a triangle. EA is the side of a triangle. AC, CD, DA, all sides of triangle. BC is not, DE is not. Those are separate parts. So if I say AB over BC, I have to match it AE over DE. Okay? Whatever you put on one ratio, you have to match with the common parts on the other one. Okay? This is what I mean by being consistent. Okay? Next, if we're talking about a mid-segment, remember, midpoints. If Q is the midpoint of this, that allows us to say, okay, those are equal segments. Okay? And R is the midpoint of MP. Okay, so if we get this information, we know 2 things. Once we have that, now we know this is parallel to this. Okay? We also know that QR is 1/2 of NP. Okay? So if this is 12, that's 6. And the converse. Okay? If that's 9, that's 18. Okay? Remember the converse of 1/2 or inverse is 2. Okay? So that's how that works. Also, look at what you've got here. If these are equal sides or equal measures, you have in a ratio a 1-to-1 correspondence. So you've still got a proportion. This over this would equal this over this because they both simplify to 1/1. Okay? Proportional parts with parallel lines. If I have 3 or more parallel lines cut by 2 or more transversals, and one is divided proportionally, then they're all divided proportionally. I could have 50 transversals going through those 3 parallel lines, and each separate transversal is divided proportionally. Okay? It doesn't mean they're all equal to each other. It means it's divided proportionally. Okay? Now, FG over GH equals LK over KJ. That's one proportion. Can you do others? Oh, yeah. Once again, being consistent is the key to this. Okay? If you remember back to when we talked about proportions to begin with, I told you as long as the cross product, cross multiplying, as long as the cross product comes out the same, you're going to be okay. Keep that in mind. It's important. Okay? Let's go over to our examples. Okay. On our first two examples, all we are doing is finding missing parts. So, get you a little bit closer here, so hopefully you can see this. Okay. I need to find CE. I have this, this, this. I need this. I'm just going to call it X. Okay? Now, I have a side of a triangle, segment, and segment. I can set that up just in that manner. So I'm just going to go 27. Okay, I went that way. I'm going to do the same here. Remember, I like to simplify first. I can see it. I don't know whether you can see it or not, but I've got this huge glare running across the top. If you can't see it, you'll be able to see it easier on the pictures. So I'm going to simplify this. Okay? 3 is a common factor. Okay? And that's your setup right there. Okay. An intelligent man would have brought his paperwork over with him. Okay? Okay, so x equals 16. The CE is 16. That's what we've got. Okay? Down here I'm asked to find 2. QT and TR. Now each has X in it, so if we find X, we're going to be able to substitute it back in. Okay, so we're going to do that again. I'm going to go 12 over 27 equals X minus 4 over X plus 6. Yes, once again, I am going to simplify. Okay, cross multiply. And solve. Okay, so we get down to X equals 12. So now we can go back to find QT. 12 plus 6 is 18. And 12 minus 4 is 8. There's my 2 lengths. Okay. Come over to our next one. Okay, on this one. Determine whether JK and NM are parallel. Okay? In order to do that, we have to see if there is a proportion. Okay? So, the first thing I have to do is this. I've got a segment, a segment, a side, segment. I can subtract and get this value right here. Okay? Or I can add together. Okay? That's the key. I'm just going to do it this way. okay? Over this over, okay? Simplify to see if they're equal. Those are not equal proportions. Those can't be parallel. Okay? Pretty straightforward for you. Okay? Now, on this one, we're looking to find the value of x. Okay? We're dealing with mid-segments here. Okay? I was supposed to have put the lines on there, but clearly I didn't. Okay. Okay, now we're dealing with mid-segments. Okay? X is the mid-segment. Its length is half of 22. Okay? Down here, x is half of x plus 7, which means x plus 7 equals 2 times x. Remember, we can do both. Watch. Because we don't want to deal with fractions, I know you guys. Multiply both sides by 2. Excuse me. So the x equals 7. Check real quick. 7 and 7 plus 7 is 14. That's half. We got it. We're good. Okay? Okay. Those are pretty straightforward and easy. I don't think these are any more difficult, to be honest with you. Here we've got 2 variables within a problem. Okay? Okay? See? Yes, I did them. See? Okay? So what I'm looking at here is this. I've got to find the x's and the y. Well, this tells me they're equal, which means they can be set up individually. I don't have to worry about equations with 2 variables in it. So I'm just going to do real simple, okay? Okay, subtract, multiply both sides by 3. Okay, there's the first one. Okay, now, I can deal with the x's. Okay? Okay, I'm going to, you've got your choice here, okay? I'm going to move that over there and move this over here. So, two ways you can look at this, okay? You can turn this into fourths, subtract, and go from there. Or we can multiply everything by the denominator and get rid of our fractions right now. That's what I'm going to do. So, by multiplying everything on this by 4, I get 12x okay? No more denominator, no more fractions. And there are my 2 answers, x and y. Okay? As I said, not incredibly difficult math. Okay? Now, again, you will notice I have equal segments here. So this equals this. The lines are parallel. That tells me that this is going to be equal to this, even though my drawing doesn't show it. Remember, not drawn to scale, okay? Just about ever. Okay? So we've got that. If they're equal to each other, that's all I'm going to do. Okay? That's x plus 1. I don't know why that's there. Not only is my drawing not drawn to scale, I didn't copy the problem right. See? Okay, so. Subtract, add, perfectly acceptable answer right there. Just leave it, okay? 2.5. Now we're going to deal with the y's. Okay? Now, on this particular one, you've got your choice. Okay? I'm going to get the numbers together and the variables together on proper sides. And once again, I give you the choice of actually turning that into thirds and combining, or multiplying everything through by 3. I'm going to multiply everything through by 3. Okay, 18, 12 cancels, leaving 4. Okay, divide both sides by the 8. And then all I did was simplify 18 over 8 to 9 over 4. Once again, you can leave it just like that. Improper fractions are okay. Okay? Despite my screw up on the copying the problem right, it's not difficult math. Every one of you can do that, okay? Or should be able to by now. Once again, like I said, the most problems come, and I just showed you that I do it too, copying the problem down wrong. As long as you set up the problem correctly, you're going to be fine. Make sure you copy the problem down right. Okay? That's what we've got.